With this question, you need to really know the properties of a circle. So what they've got here is they're saying, here we go again, right, they're saying the radius, so r equals 15, and they're saying a to b equals, is that 27 centimetres. So what we've got is from a to b is 27, and we know that the radius is 15, so that must mean a to c equals your 27 minus 15, which equals 12. Okay, so from there to there is 12, and from there to there is your 15, because from there to there is 27. Now, property of a circle, if you have a tangent, you can actually create an isosceles triangle using the centre of the circle meeting where the tangent meets the edge of the circle, and the distance is actually equal to the radius. So you end up having an isosceles triangle in which two sides are the radius. Now another property is that meets the tangent at right angles, or sorry, not the tangent, the chord that cuts through. Okay, so tangent, remember, that's when it just touches the edge of the circle, right? So that's wrong terminology there. But essentially what we've got here is we've got a right angled triangle, and again redraw these out. So that's P, that's A, and that's C, and we can now actually put some values here. So R is 15. Now this isn't to scale. We've got A to C is 12. We'll just say that's x. So what we can now do is use Pythagoras theorem to actually work out what x is. So what we say is x squared equals, remember, if you're finding one of the shorter sides, it's a long side squared minus the other shorter side squared. Okay, now remember you have to do, it's paper one, so it's non-calculator. So 15 squared, 15 times 15 is 225, minus 14 times 14 is 144. Again, do the working out on your paper, and that equals 81. Okay, so x squared equals 81, so that must mean x is the square root of 81, which equals 9. Okay, so that is 9, but obviously it's p to q, so that's just double that. Okay, so p to q is 2 times 9, which equals your 18. So again, think about if the chord intersects at two places, then we can create an isosceles triangle in which two of the sides are the radius. Right down the middle is right angled, so this isosceles triangle you can half, and the result is a right angled triangle in which you have two sides, and if you've got a right angled triangle and you know two sides, you can always work out the third one using Pythagoras theorem. And that let me work out half of the length, and then you just double it to get the full length. So that's that question done.